Welcome to the BBC Micro stream. We got up to the sound command where I couldn't get it working. Well, for some reason it didn't work last time, but it does work now. So I think it's because we were messing around. So the sound command is very similar to the sound command I wrote in the graphics package. So you're telling it which channel. So there's 4 channels, so we're using channel 1. Amplitude. So A is a value between 15 and 4. 15 to 0 produces notes of fixed loudness throughout the whole note. And then 0 produces silence. But I don't know what it's values of 1 to 4 enable the amplitude to be controlled while the note is playing. Okay. Whatever. Then we got pitch. This is all gobbledygook to me. So I presume that's the frequency. You got it working. Was it the path, mate? Was it the path? Go on. Tell me. Oh. Okay. Reinstalled Beeb emulator. Well, it's working now. Good, good, good. So pitch, I think, is the sound. But I don't know what that D is. What's D? Oh, duration. Can be any value between -1 and 254. Values in give a duration of the number of 20ths of a second. So D equals 40, the note will last for 2 seconds. Okay. So what we've got here, channel 1, maximum volume, a tone, and it's going to last for a second. Okay, let's see if it does it. Yep. So they're saying if we put a positive value in there, 4. Nothing. Don't believe what you read, John. See. There we go. So we've got sound working. Now in conjunction with envelope, which I have no idea how it works. Oh, noise. So channel 0's noise. Okay. So channel 0's noise. And then 1, 2, 3 are the other ones. Right, so we should be able to put that in then. Better make sure there's nothing in there. God, sounds like a rocket. Right. The envelope. I struggle with envelope. Let's go to envelope. I struggle with envelope. Because is it ADSR or is it not? The envelope statement used with a sound statement to control the volume and pitch of the sound while playing. All natural sounds change in volume, loudness and amplitude. For example, the sound of a piano starts off loud and then fades away. An aircraft flying overhead starts softly, gets loud and then fades away. Okay. So let's see what this does. So an envelope. N is the number, so we can have 1, 4. T, length of each step in hundredths of a second. Right, so this one is 1/100th of a second. Next one is P1, change of pitch per step in section 1. This is where it just goes. Oh, it just goes above me. Okay, so we are in, if I'm reading this right, so that's yeah. I mean, it for what it was built for, it was good, but it's no SID chip. So phase 1 goes up by 4, phase 2 goes down by 4, phase 3 goes up by 4. Okay. Number of steps. So it does 10 steps and then 20 steps, then 10 steps. Oh, this is not going to work, is it? Because I have to do my rescuing, don't I? There we go. So 10 steps, then what, it comes back to 127, so that's the change of amplitude per step in the attack phase. So we've got no decay and we have got no sustain, and then we have got -5 in the release, and then it's the target level. Oh right, what it's got to aim for in attack and the target level of the end of the decay. Okay, so the last bit is all right. Okay, let's run it, let's see what it does. Right. So bit 7 is auto repeats. That's T. So T wasn't repeating. Auto repeat the pitch of the envelope. So we should be able to repeat this to 129. Bust it. Bust it. At least it stopped. Bust it. Well, I suppose. There you are. I just don't know it. I just don't know it, does it? So it must be the pitch changing. It must be this. Anyway. So back to sound. Oh, come on. Tell me you're not. I thought you would have been linked. Like you was linked back to envelope. MNOPRS. Anyway, sound. So the sound kicks it off and then the envelope takes over. So that's how it seems to work. It seems to work. Still a black art for me. Still a black art. What's this doing? Stop! No, I'm not doing that again. Yeah. Sound is what to play. Envelope is how to alter it. Right, let's see what this one does. Yeah, don't like those. So, I mean, sound is a black art for me. But at least it's working. I mean, envelope will take some getting used to in my ears. Anyway, let's carry on. So, SPC, space, well, we know what that is because that's in the Commodore language. That's just, you know, putting 6 spaces at the point where it wants it. Square root, obvious what square root is. Step, well, we know we talked about it in the 4s. Stop, that stops the program. So that's the same as end in the Commodore. String converts a number into a string. Ooh, string. Oh, right, okay. How many times you want to repeat a pattern? Okay. So that, okay. So print that. Well, that's not going to work, is it? But this will. Print. Hello.
Hello. Do you have a ruler?
A ruler.
Yeah.
A ruler. I have different types of rulers.
That'll do.
Will that do?
Yes, thank you.
All right.
Sorry.
That's all right. Is it? Stop is different. It doesn't. Oh, right. Okay. So this is going to, according to what I read, this should print that --O 6 times. Nice. Why can't we have that on the 64? Simple commands. Tab. We have a tab on the C64, but it's only horizontal. It's not vertical like this. Tangent. Yeah. Then. Oh, this is something which... If. Then. Else. Oh. Just throw it in my graphics stuff. Oh. Right, okay. Yeah, there's a continue. Is there a continue in the 64? Oh yeah, there is. Time. Well, this is equivalent to what? TI. What's add val? Where do you see add val? I was someone messing around with my... Oh, you can't see it. It's the camera's moved, hasn't it? There we go. Camera's moved. I've got to dig out my... I've got to dig out the traffic lights. Stick them on top. I thought of running some cables so I could have the traffic lights down here and then I could see when... At the end of sound. Oh, we've gone past sound. Hang on. Oh, I don't know. What page are we on? 353. Analog to digital converter. Oh, this is the joystick. Yeah, because the BBC joysticks were not switch orientated. They were potentiometers. There were potentiometer joysticks. I think I have got a set. I think I've got a set from my dad's BBC. I'm not going to say that. Why? Is it because they were analog? You couldn't keep anything still. If you was holding the joystick, you couldn't keep something perfectly still. It was just still moving around just a little bit. If you wanted to hold it really still, or the fact that the joystick after a while just went through if you let go. But yeah, well, that's because you can't keep the joystick absolutely still, and because it's a potentiometer on both axes, it will feel it would yeah. 353. Where are we? Oh, 400. Oh, went way too far. Da, 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 da. Right, time. Like the 64 Ti. I think it registers hundredths of a second intervals. I think the 64 was based around the screen hertz. I think wasn't it 60 ticks for NTSC and 50 for PAL? John, just press the page divided by total pages and jump to the page you want. So this is a hundredth of a second, so they worked in a hundredth of a second. On the menu bar, yeah, I see it. Well, we're on 364, so we're not far away, so it's actually 2 pages. I'll remember that. 2, that's part of the 4 next loop, we know what that is. Top, the function top returns the address of the first free memory location after the user's program. Ah, right, okay. So this would be the equivalent to 55 and 56 is top of basic, so it must be 53 and 54. So that's what top is. Trace. Ah, this is something I wanted to write on the 64. So if we do new, paste that in. Now I think you just trace on, don't you? Yeah. So now that's now told the basic interpreter to let me know what line numbers are running. There you go. So it went 10, 20, 25, 25, 25, 25, 25, 25, 30. That is what I needed. This is where Disney films came from. 10 points, if you can name it. Oh, I see. I see. Nice fact, mate. Nice fact. But this is what I wanted to. This is what I wanted to do on the 64. Because I did write a programmer's aid program that allowed you to set the function keys, renumbering, and loads of other stuff. I think programmer's aid. That's what I call. Well, I called it something else, but it was the programmer's aid. But trace, I couldn't master trace. I didn't understand the basic interpreter enough to do the trace. Now I could do it. Now I could do it because we would just intersect the bye-bye routine, and in the bye-bye routine we would find out what line we're on, and then display the line. So I could do it now. I couldn't do it as a kid. But the programmer's aid cartridge for the 64 allowed you to see the line. I think it put the line at the bottom of the screen, the entire line it was on. As this is just, this trace is only just giving you the line number, so it's showing you what it's doing. Right, true. Well, we know what true is. That's opposite to false. Until is the partner with repeat. User, right, this is important if you want machine, I think this is important, machine code, yeah. So user allowed you to run, so it's the equivalent to sys, yeah, in the Commodore world, it's equivalent to sys. Can you affect the registers? Provides the user with the means of calling sections of machine code programs which are designed to return a value. Ooh. Well. Okay. When the machine code section is called, the computer sets the processor's A, X, and Y registers to the least significant bytes of A%, X%, and Y%. The carry flag is set to the least significant bit of C%. Right. On return from the machine code section, an integer number is generated from the 4 registers P, Y, X, A. Most significant bytes to least significant byte. Okay. What's P? Oh, P. I know what P is. Again, it must emphasize the user returns a result, whereas call does not. Yeah. So it combines P, Y, X, and A into an integer value. What's that? A 32-bit number. And we have to set A%, X%, and Y% to do it. Ooh, we'd have to try that. We'd have to try that. Because I do call, done it in my A level. Value, that's converting a string into a number, if it's a valid number. And also does date as well. Never knew that. Well. VDU, here we go. Statement VDU is followed by one or more numbers, and the ASCII character corresponding to these numbers are sent to the screen. The function CHR can generate a single ASCII character from a given number. The character can be added to a string or printed. VDU, on the other hand, is used to generate a sequence of numbers that can be sent to the VDU drivers. So basically VDU and then number is what it's gonna do. So it's very similar to print and, you know, CHR13, which is return and stuff like that. As this one, 28, video 28 allows you to set the XY coordinates in mode 4. So these 4 bytes represents the left X, bottom Y, right X and top Y coordinates of the text area. So that creates a text area in mode 4. 24 is the graphics area, which we've already played with. Ooh, auto paging. Oh, this one. This is the same as going up in Commodore, going open 4, 4, and then I think it was CMD4. That means it sent all the output to the printer. So you do video 2 to turn the printer on, so it sends all the output to the printer. Is there not a list of VDUs? We'd have to look. Vertical position of the cursor. VPOS is used to find the vertical position of the text cursor on the screen. Okay. It's in the appendix. Okay. Width. Width is used as the overall page width the computer uses. Initially, this is set to 0, which the interpreter interprets as unlimited width. Width N would force... Right, okay, so you could do width 60. Alright then. Let's do width 20. Right, run. Oh, did I get rid of it? Oh. Ah, hey! Nice. Oh, never. Didn't know that. Here we go. VDU drivers. So, 24. No, it's not 24. 23. 23. That's the one I use the most. Reprogram a display character. But basically, this VDU, the number does something. So how would it have been to have, you know, in the Commodore at PETSCI that print CHR23 and then use some numbers after that to redefine a character without having to do any work whatsoever? Would have been brilliant. So these are just three disables a printer, okay. Yeah, VDU 23 was the one I used the most. Redefining characters. Seven, this code is entered. As VDU 7 or direct from the keyboard as Control G causes the computer to make a short beep. Does it? Control G. Oh yeah, so it does. VDU 7. Hey! Video 8 moves the cursor one space to the left. Right, okay. So each one of these performs a specific... Yeah, VDU 13 is the same as character 13. So it does a... Yes, it is. Yes, it is. Character 7 is the bell on the pet. So VDU is quite a really, really powerful command, especially in BASIC. Really powerful. And there's the redefining the character. VDU 23. Tell it the character you want to redefine, and then give it the 8 bits of data that you want. But it only works in... No, it doesn't work in mode 7. It doesn't work in mode 7. So, that's VDU. I mean, that's bonkers. Oh, it even gives you the mode. No, mode 4. That's big enough. Let's put this lot in. Let's help it out a bit. Get rid of that. Get rid of that. Right, so VDU 224. There we go. Right, VDU 224, 225, 226, 227. So we should get all the 4. There you go. How easy would that? How brilliant would have that been in the Commodore, in the 64, just to be able to do that, and then look, you've got your redefined characters there just waiting for you, instead of all them messing around with the VIC chip. Would have been brilliant. Right, cassettes. We're not going to go into cassettes because saving and loading is just the same. I think that's it. I think that's it. Right. Ooh, FX, Star FX. We haven't got into Star FX. Ooh, don't fancy getting into them. Now you know everything. And know enough to be dangerous, yeah. Oh, right. Star FX. These are, yeah. It's like mini machine code routines, these things are. Anyway. So we know now how the basic programs. Now I did a little bit of work. Right, because I did this. Here we go. Does everybody remember this? Does everybody remember it? Let me blow it up so you can see. Does everybody remember this? One of the cassette 50 games. This was the basic program for line them up, yeah? That we then converted into machine code and optimized it for the cassette 50 games. Well, the actual code itself, when I developed it on the 64, had no customization in it whatsoever. So we should be able to copy this, new 07, and then just paste it straight in. Then we should be able to do list and then run. My move. Which column do I want? I want 4. 4 again. Three. Where are you going? Where are you going? Let's throw a 6. Let's throw a curve. Well, we've got to do 4. Can't allow him to get away with that. Oh, I think I may have him here. 7. Oh, thought he got you. Alright then. 6 again. Oh, I'm not winning. Oh, 5. Now I should be able to... Yeah. 5. 3. Here we go. So, 6. Oh, we missed it. Yes, get in there. 6. Hoo-ah! Hoo-ah! Ah. Right. Now, we could change this so it could do colours and stuff like that. But it just shows you that a Commodore game that's just a normal text-based game, right, can still run in BBC Basic. And that's where some of these books come from. Here we go. So, something like that, where there was no special goings on, but these games could be written on all the 8-bit platforms. So as you can see there, it got Spectrum, BBC, Electron, Dragon, VIC-20 computers. Well, it could do 64 as well. And only because they used standard basic. I mean, they did have customized routines, which were, where are they? Here we go. So it was the library of routines. So that's the Spectrum, the BBC and the Electron, VIC-20 and the Dragon. And what it was they had a set number of libraries. Yeah, so 1,000 names the subroutine library, and there was 1,200, 1,500, 1,700, 1,800, 1,900, 2,000, 2,1, 2,2, 2,3, 2,4, 2,5, yeah, all the way to 3,100. Yep, yep, yep. And some routines were bigger than others, so that's the Spectrum, I think. Yeah, that's the Spectrum library. But then you've got the BBC library, which is pretty small, but does exactly the same thing. So this book is just basic games. I mean, there's let's see what's in here. So we've got Bomber, Stupid Fish, Swiss Navy, Hit or Miss, Fruit Machine, Zigzag Golf, Road Rage, Squash, Xmas Zombies, and then we've got Thinking Games, which is Pyramid, Dragon, some Trouble Primes, and a lot of other things. Number puzzles, scientific puzzles, word puzzles. But because the core basic across all the platforms were essentially the same, then you could take one of these books and apply it to whichever machine, which we've just done. We've taken my line 'em up game that I did for the cassette 50 competition, and because we'd done it in BASIC to start with before we converted it to machine code, just pasted it into the BBC emulator, and it just runs as intended. Admittedly, it's just a text game, it's in black and white, but that's where the customization of being to do in the BBC, because we could then say down like here, we'd have to work out how to set the colours. How do we set the colours? Is that a VDU? I doubt if that's a VDU number. Can we set the colour? No, doesn't look like it. I thought we could set the colour. Define text colour 17. Video 17. No, I'm thinking of character. VDU 17. So VDU 17, comma 2. No, okay. Oh, I thought you could print the colour light in the 64. That'd be annoying. Define text colour. You know, like doing function 2. Or is it control function 2? There we go. Well, we can do that. We can do that. So I need line 1140. Right, so we'll leave the dot as a white dot, but we'll say,
Oi, John, pay attention to chat.
I know I'm in mode 7. Oh, this won't work, will it? Because I put a space in there somewhere, don't I? Where's the grid? Draw grid. Yeah, I put a space. I just don't have the space. That solves that. Right, so we're going to change this. So we're going to say a human will be marked. Oh, right, okay. A human will be marked in green. So green is control function 2. And then do H. Oh, da, da, da. Well, that's not doing much good, is it? Oh, cobblers. How can we set the colours? Alright, mate. I'll come and I'll log on to your stream at some point later. I thought we could set the colours in mode 7. Yeah. How'd you turn that off? Use mode 6. Okay. Right, okay. So would that make it, that would make that H green, would it? Colour, colour. Yeah. So that H will definitely come out green, yeah? Okay. So we'll make the computer... Well, that's not going to come out right though, is it? That's not going to come out right. Because I'm doing the ASCII. I want to colorise. I want to colorise what's coming out. Yeah.
Oi, John, pay attention
Yeah.
to chat.
Yeah, I saw it. Yeah, I saw it. See, that's not yellow. Right. There's a routine that prints out a matrix. So we'd have to change this. We'd have to change this to make it print out. Mode 7 can have colours. Sure of it. I'm sure Mode 7 can have colours. Oh, it needs control characters. Use the... okay. Okay. So you're on about here, yeah? Well, mode 7 was control. F2 gives you gray, yeah? F3 gives you yellow. 5 gives you pink. 4 gives you blue. That's what I was thinking of doing. Was just putting it in here somewhere. So we'd need to put a test in there. Yeah, we can do that. 900. Ooh. Forgot the comma. So we want to try... I'm trying to colorize the grid, yeah? So we could do 901. If this equals H, then print no, I don't want green, blue. Ooh. So that would print the blue character for that. So we need to copy this again. 2. If it equals the computer, then print red. No, 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 no. Nope. Nope. What's red? Ah, red. And then we'll do the same thing again, but this time bring it back to white. Equals dot. And print, what is white? That's black. There we go, white. Nine oh 32. Oh right, okay. Well spotted. Right, see what that does. I think that's going to screw it up. Yes, it did. Oh, we've still got the mode in there. Yeah, get rid of 5. And we are missing...
Oi, John, pay attention to chat.
Yeah, I'm doing that now. So this, we do not now need this space here. Ooh, go back. We don't need that space because we got the control character beforehand that creates a space. Oh, but the dots are coming out. It's just that's stupid. Oh, full stop is that. So it's put in graphics mode as well. Yeah. Oh, that's FIC 20. It's only 4 colours though, isn't it? Yeah. No, I don't need it. I was just trying to think. So, colour 1's red. Colour 2 is yellow. Colour 3 is white. And colour 4 will be black, won't it? Yeah. So, let's see. Oh, I've just seen AMK. Okay. There you go. So instead of doing that, we will set the colour. So for the human, we'll do 0, 1 is red, 2 is yellow. For the computer, we will do 1, that's red. Well, you're moderator, Andy. You can add another 3 to him if you want. Well, go for it then. Add another 3. You have the power. If you disagree with me. So colour, right, 1 is red, 2 is yellow, 3 was white, wasn't it? Right, so we should have colour now. No, we shouldn't. Let's have a look. Yeah, it's 9:40, isn't it? 9:40.
Oi, John, pay attention to chat.
Put the space back, yeah. Oh, AMK points battle here. Right, so 9:35. We need to put it back to white, so that's colour 3. So it prints the bottom okay. Right, let's see. There we go. Right, human was going to go into 4. Oh, I've got the colours wrong. Oh, I've screwed some up here. Well, that's where you put a C. Why is the colour not coming out? Well, would you believe it? Colour 2's black. What mode am I in? I'm in the wrong mode, aren't I? Was it 4? Yeah. Still got the wrong colour. No, it can't. It was the Vic. It was the Vic mode, wasn't it? So that's mode. Nope. It's that one, isn't it? Yeah, it's mode 2 we need. Oh, VIC-20 mode. It's not put itself down. Okay, I'll take advantage of that. There we go. Ooh. There's a bug. It doesn't like some of my movements. Oh well. Anyway, that's to show you how you can take a bog standard text game that will work on anything and put it into BBC, and it should work off the bat, as long as it ain't got any custom stuff in there, like you know, custom graphics or anything. It should work. Now, machine language. Ooh, yeah. I'd have to get my project out. Let's find my project. Where did I put it? Where's my? Should I put it in there? Oh yeah, there it is. So machine code, this is machine code here. Now you can embed machine code in a basic program, and the basic interpreter will evaluate it, assemble it, and then put it into the memory that you want to do. Now unfortunately I don't need to save that because I've already got it. I haven't typed it in, so I could type it in now and see if we could get it to run. So let's use the same line numbers there and see if we can do it. So 4C equals 0 to 2, step 2. So if I make any mistakes, shout out. So this is set in where I want to put the code, and then we start this. Oh no. Right, so we're alright so far. So the first one is LDA hash. Haha, keep forgetting to put the line numbers in. LDA. Now it's not a hash, it's an ampersand. 12. But it's not, is it? It's a pound sign. Hash. What is going on with my phone? Hang on, guys. That can wait. Work can wait. Right. It's this is, well, yeah, the printer makes it a pound, yeah.
Oi, John, pay attention to chat.
Yeah, I saw it. I saw it. I saw it. So this JSR here, now it is ampersand for this FFE3. That FFE3 is the same as FFD2 on the Commodore 64. It's print a character. I know that for a fact. The thing is, I'm looking down here and I'm worried about that there. I don't know if you guys can see it. Let me blow it up. But I am worried about this. I'm worried about that. Let me see if I can find the code in actually the explanation of this. There it is. Oh, it's there as well. Oh, what is going on? I'm not sure that that's right. I am not sure that that's right. Oh, you could be right. I am sorry, my younger self. You could be right. 7DEC. Yes, that is a screen location, isn't it? Yeah, it is. It's a screen location. Because the screen's mapped all the way up the top, isn't it? I apologise to my younger self. Apparently my younger self knew what he was doing. Dear. Oh, really? That code is a nightmare, isn't it? Anyway, we'll go back to the original. We'll go back to the printout. Let's see if we can type this in. And see if I can remind myself what it does. I think I know what it's doing. Right, so we're... So 4490 LDA #0 4500, store it in ampersand 7. That looks like an 8 to me. Yeah, I think it is. So number of rounds. Okay. So 5410. So dot start. Oh, hang on. Start. Lowercase. Come on, lowercase. Left alt. Left alt. No. Caps lock. Yeah, caps lock. Right. LDA #0. Now, why am I doing that again? Go, inexperience here. 72. Yeah. 73, 45, 40, 70. 74. Oh, let's do this properly. Let's have some spaces in here. Oh, I've forgotten how to use the auto. Hang on. Right. Oh, start interval. Okay. Start interval. So we're going to start at 4560, comma 10. That'll do. Right. 4560. Right. LDY hash 0. Right. Dot print space LDA text, comma Y, store it in 7DEC, comma Y, just scroll that down a bit. Scroll that a bit along. LDA 7A. So print, branch print LDA 78. So A. Oh, I keep forgetting the colons. Oh, I'm missing something off the end. Or am I? Oh, no, it's that. CLC, ADC, 128, 129. Seven DFB.
Oi, John, pay attention to chat.
Yeah, it's there, look. LSR8. Yeah, I know, BBC commands have to be in capitals. Right, so we've got that big line in there. I reckon I did something wrong there and I had to squeeze it all on one line. Right, LDA hash ampersand 7C. Store it in 71. LD hash 39. Store it 75. Hash 24. Store it 76. Right, dot next. LDX ampersand 74. Oops. LDHR comma X CPX hash 0 DNE next one LDA hash ampersand 78 LSRA CLC ADC hash 129.
Oi, John, pay attention to chat.
Spotted. Spotted. Give yourself some points, mate. That's Doxter. There you go, mate. I gave Doxter 5 and you gave yourself 10. Okay, right. Auto 4660, 10. Right. Dot next one. STA 77. LDA 78. And it with 1. CPY hash 1. Branch if not equal to. Ooh. Top minus 2. Uh, 72. I have no idea what I'm doing here. CMP hash 1. BCC top minus 2. What else we got? Colon LDA hash 32. Store it in 77. Right. LDY ampersand 72. Oh, here's dot top. LDA 77. Store it. Oh. I and Y. God, what am I doing? CPY 75, branch if not equal to top. LDX 73. 75. Right. We're on dot. This is what I'm about to find out. I can't remember. I have an idea, but I'm not actually sure. Because I wrote loads of stuff for my A level in machine language. You know, Pet Frogger for what? Pet Frogger was one of them, which I made a video about a couple of years ago. So I'm not too sure. So it'd be interesting to see what happens. So 4470 is storing 70,y CLC LDA 70 ADC hash 40. Ooh. Oh, can't get used to this. L. DA. Thank you. Add 0. Store it. 71. What happened to the space? Oh, I'm just trying to type it in. Shut up. Oh. I dropped back into programming. Back then, spaces were a waste. But I am thinking I know what this does. I'm thinking I know what this does. Just by reading the code. Oh, LDX 76. Why is that space there? Ugh. LDY 72. Right. Dot left. LDA. Store it back. I think this is going down the screen. I think that's going down the screen. 5050 DX CPX with 73. Oh! Right, I'm getting rid of that space, it's doing me nothing. Do that as well. Right, dot left. Oh no, it's left, isn't it? Right. Oh. Did my stream go off? Alright. Another long one. Okay. My chat reset, that's all. Right, so that's adding 40. LDX hash 32. Alright, dot DEL1. LDY hash 255. My dad's going back in next week for the surgery that they stopped halfway through. He's going they're going to have another crack at it. Next week, so we'll see how they do next week. This looks like it's a delay. Yeah, this looks like it's a delay. Right, so ink 72, decrement 75, ink 73, decrement 76. Okay, ink 74, LDA 74, CMP 12, branch if equal to next 3. Great labels these are. Jump next. Right, dot next 3. Oh. 78. Branch if equal to next 4. Jump. Start. Yeah, you're right, Andy. I jumped back there, so right. Next 4. RTS. Right. Close off. So char equals P% colon $P % equals, here we go, oops, oh, there is a quote there, you just can't see. There is a quote there, you just can't see it because I bet there was a control character. So, bank. Call. Right. That's it. Right, let's save this first. Have I got my disk loaded? Where was that?
Oi, John, pay attention to chat.
No, I didn't define it as a proc, mate. So I've just left the. I didn't define it as a proc. Right, protect 0. So right, okay. So right, so that's not the disk. Where was my disk? Did I put it in? Yes, there it is. Right, save Machine code. Oh. Oh. Right, we'll save it just to make sure. Now, as far as I understand, this will run through twice and assemble it, and then here we are going to call it twice. Let's see if it runs. Let's see if we get any error messages. Syntax error straight away. 4560. Oh. Colon. Space after the label, yeah. Yeah. Oh. Right. No such variable. 4640. It's my typing, mate. You definitely my typing. What was it? 4640. Char. Okay, hang on. No one spotted that one. Oh, it's amazing how you start dropping back into saving every time you make a change, isn't it? Yeah. Yeah. Right. Oh. What's missing there? Oh. 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 Oh, hang on. Del 1. Am I? No, 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 no. Del 2, DE1. Del 1, DY. Branch if not equal to Del 2. Okay, that's where it's grown. Two, then DX. Branch if not equal to Del 1. Right. Oh, what? Out of range. What's out of range? Oh, missing a character. Missing a character. 4. You're melding into the BBC keyboard like you'd never left it. Yes. And also saving every time I make a change. It's getting ridiculous, this. Oh, I'll be glad when we move to the VS Code situation. Right, let's see if this runs now. It's got to run. No. Really? Next 4. Next 3. Next 4, jump. Where are we looking at? 5100 to 5200. Next 4's there. No such variable at line 5120. There is own. Oh, start. Oh, look at that. It's missing a T. Ah, dear. Right, here we go. Let's see. Fingers crossed. Whoa! Whoa, 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 whoa. It's not quite right. It's not quite right. And why is it not quite right, John? Let me run it again. It's this here. This here. Back to Scotland secure server. So this, it's here. Let me just do this. I'm just wondering if my count is too much. So that's text. So where am I messing around with text? There. 15. I think it's more than 15, to be honest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I've just now done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right, that should be right. There we go. There we go. I know how to entertain. Oh dear. But that that was the intro screen to my project, right? That was the intro screen to my project. Now, looking at it, looking at it, I went around this. I went round this really bad. I mean, I can see a load of places where I could make it better. But spirals. I should have sent that into the spiral challenge, shouldn't I? Oh! Oh dear. Yeah. But this, because this was my A-level project, I'd written most of this in assembly, right? I'd written most of it. But I was told I could not submit it because no one understood what I did. But I wanted to show them that I could do assembly so I did the title screen in assembly and then wrote the rest back in basic. But as you can see, all this is doing is it's the colours. It's just doing the colours, isn't it? Yeah, so it's changing the colour every time it does it. So why do I call it twice? Why do I call that twice? Well, I mean, I could do this front screen in basic. Everything else was in basic, as you can see. It was a check-in program. Yeah, I'm just it's there, it's twice there. So let's take one out. Let's take that one out. Let's run it now. Was that shorter? Let's time it. Stopwatch, where are you? Stopwatch, right. Here we go. Right, that was 3.5 seconds. So if we put 5190 back in, let's do another run, reset, get my thumb over it, ready, go. Yeah, it runs twice because it's 7 seconds. So it runs. So yeah, it runs twice just to make sure it's. But there is a delay in here, which is here. Oops, let's do that. There's a delay here. So it's loading 32, 255. So it's running through it 32 times. So I could slow it down by increasing that number or decreasing it. Right. Let's see how fast this thing can go. Okay, hang on. Right, let's see how fast we can make this do it. So if we drop it down to say 2, 2, and we'll see how fast we can get it going. Here we go. Here we go. Strobe warning. Strobe warning. Here we go. Oh, wow. Slow it down, okay. Hey, Bumbly Coder. Let's oh, I think that's it, yeah. So 5180 for I equals 0 to 5. Right. Here we go. See how... Right, so this is on mega fast. Dear. That's alright, mate. We're just doing inline assembly coding on the BBC. And that was almost as fast as it will go. I think, yeah, if I put 1 in there, I couldn't put 0 in there. 0 would make, I think 0 would make it slow. Slow. Because that would be the maximum, I think. Alright, here we go. There you go. So I'm changing the... I must be changing the colour. Yeah, this is what it did. Well, this wasn't the 90s, was it? This was the... when did I take my A level? 80... What's the date on this? What's the date on this? 85. So, well, I don't know if I can we escape out of this? Can you escape out of a machine code program? No. Oh, yeah, we can. So, 0 is the slowest, so I had it at 32, didn't I? So it's sort of pretty quick. So, let's see if we can try and decipher what I'm doing. There we go. So that was the actual effect, yeah? That was the actual effect that I put into my A-level program using machine code. So, let's see what we're doing. So at some point we're changing the colour, and I'm wondering if it's this 7D FB. So put some text on the screen. Right, Andy, how do I do a poke? Is it question mark? Yeah, okay. Well, that was a stupid number. Let's try a different one. Well, it can't be that then. My assignment for next week, change the animation into a spiral. Yeah, I suppose. Oh, I'm trying to 7dBF. I'm trying to figure out how I change the colour. It's got to be this. So I'm printing the text out there. So I'm printing this out. Right at the very top of the screen, I'm printing that. So I'm printing the centre. Then I'm loading 78, dividing it by 2, and then adding 1. Oh, I'm adding 129. Oh, okay. Okay. Oh no. Right, let's try that again. So ampersand 7dFB equals, right, so I'm adding 129 and then storing it. So let's say let's do 129. Aha! We have red. Let's do that again. So make it 30. We have green. So, what's so special about 7dFB? Let's see if we can find something. BBC micro memory map.
Oi, John, pay attention to chat.
What is peace percent set to? 6,000. I'm just seeing if there's a memory map anywhere. But I wonder if this will shed any light on it. BBC revealed. Oh, there's no index. Registers. Okay, here we go. No. I just want the memory locations. Oh, I bet it doesn't go all the way. Okay. So, clearly this byte here, this location here, is changing that. So let's go back to my A-level project. So here I'm printing the text and then I'm changing the colour. And just this location here. And then it looks like yeah. So this is setting up the start, right, so this is setting up the start coordinates. Alright. Oh, add 10 to the FB you mean? Okay. Oh, now you're asking. You have to make it difficult. Let's do it here. Seven. Oh, make it FF. Okay. Oh, it's moved. It's moved. So I'm loading 7DEC. So I must be putting a control character somewhere there. Yeah. Seven DEC, 7DFB.
Oi, John, pay attention to chat.
Yeah. So here, so this is where we are. So we're loading the character from here. So this is the text that's used in the border.
Ladies and gentlemen, 6502 Kebab has entered the chat.
Really? Really? Has he? Has he now? Hello, you. Right. So I'm loading. So we understand that bit up there. This bit. So then I'm loading the characters. And it looks like I'm going backwards as well. CPX was 0. Then I'm logically shift right. So that's divided by 2. And then adding 128. And then I'm storing it in 77. So what am I doing with 77? Right, what am I storing? 77. So 0's in 78. So what's going into 77? Crikey, John. What, 78? 71, 75, 70, what? Oh, here we go, 77. Okay. So I'm storing... Cool, it's difficult to read like this. So, right, 7C into 71. So where's 72? 72 is storing 0. Okay. So, right, let me just... let's get some stuff on the screen. I wonder if I can make that text in the middle be a different colour. I wonder if I can... I wonder if I can make that text in... Right. So, poke, ampersand, right, so it's 7C, 00 equals 130. So that's at the top. So that's at the top. Right. So 7, so, right, what's the other number then? 71. So, am I just printing the character out? Am I just printing the character out, or am I just storing the number and I've already printed the characters out? That is the question. Clear screen. No, I'm printing the character out at the same time. So adding this 129 is printing the character and the colour. Is that right, Andy? Adding 129, is that printing the colour and the character at the same time? I don't know, mate. I don't know. Because I'm certainly adding 120. I'm adding 129 here. So I'm loading the character in, testing for testing to see if I've run out of characters. If I haven't, no, that's CPX branch if not equal to here. So I'm storing it in 77. So I'm storing the character in 77. So loading 77, storing it in 70. Hang on. This is testing for X to be 0. So I'm set... Right, okay. I'm setting this first character here. I'm setting the first character here to be the colour. So if that's 7C, if that's 7C00 and it's 40 characters. So let's work this out. So ampersand. Right. Did I leave the calculator open? No, I didn't. Right. So 7C00 plus, and we'll do 6 lines. 6 times 40. 6 times 40 is 28 equals, so 7C, let's do that. So 7C F0 equals 131. So if I'm right, that's the 5th line down. So that should be this one, because we're going to change that control character there. Oops. And like a Wally. Got it wrong. 0. No. Ugh. So still this line here, I think. So that M should disappear. Oh no. Did I time it? 0, 1, 2, 3, 4, 5, 6. That's that one. Okay. So it looks like this column here is setting the colour. So I'm setting yellow there, which then makes that entire row yellow. And that's what's happening here. Because what I'm doing is I'm loading the character in, comma X, yeah? So, and because I am going backwards, or am I going, no, am I going backwards? Hang on, where's X? So I'll load X with 74. So I'm looking for 70. No. Oh, no, I'm increasing it. Right, there. So I'm increasing it. So I start at 70. I start at 0. So 74 should be 0. Yeah, there it is. So I am loading the character in. But if the X is 0, then I'm loading what's in... Stop it. But because it's the first character I'm printing, I am actually adding 128. And then I'm storing it in the first column. And that's how I'm doing the colour effect. Hooray! Figured it out. Figured it out. So that's the colour. Yeah, it is.
Hi, John here. Another subscriber. Stay a while. Stay forever.
I've got 2 subscribers. Yay! Make the bank account text white all the time. Well, I mean, what the way I'm doing it is I'm doing the line, yeah, and then I'm going in one, and then I'm loading the next character and doing it. So technically, the spiral is not a million miles away from this. So what I read all the time, yeah. So that's how you embed machine. Right, okay, let's see if this will slow down. No, it doesn't. How do I slow the text down, Andy? When I'm listing, is it shift? No. Ah, there we go, shift and control. So this is how it, whoa. Oh, I'm going to do it from here. So this is how it works. P% is the program counter point. Yeah. So when you're assembling, P% has got to be specified. Yeah. So that's how you do it. Now, I'm not too sure what opt-C is. I think that's just reporting. I think. But anything that's within the square bracket is then assembled. But the thing is, you have to do it twice. You have to tell it what C is. So C is going to be 0 and 2. Now I'm not too sure. It's the pass value, is it? Yeah. So it runs through it the first time with opt 0 and runs through it, and then the next time it runs through it with opt 2. And it assembles the code into that position. Yeah. Then, but the beauty of inline machine language is you can pass in variables. So here we go. I'm saying that char, the variable char, is the current P%. So the current program counter. And then I'm storing that text into that where that program counter is, and that's why I'm doing the manual increase of p% there, because that's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. Then I'm saying the text variable is now equal to the current program counter. Store the string at that position. And then that's it. And that's how the program is stored. So once I've finished doing the next, I call it twice. Or in this case, I now call it 6 times. And that's how you can embed machine code into BBC Basic. Now, if you want to have a go, by all means have a go. Yeah? It's safer to dim the variable and assemble to the heap. Yeah. I challenge you to do the spiral in the BBC. Right. I challenge you to do the spiral in the BBC using inline basic like this. I might using inline basic. Yeah. So using assembler in basic. Yeah. Now I typed it in. Oops. Oh, why is my there we go. Yeah, there is. You used always Nortan 3. Okay. Let's change it. Let's see what it does. Why does that say 90? Okay,
Ladies and gentlemen, 6502 Kebab has entered the chat.
Has he? I doubt it. Hello. Thank you for the subscribe though, Andy. Much appreciated. Right, I'm doing running 3. What? So Norton 3. Ah, right. Okay. That is a personalised entry for a certain 6502 kebab. Right, so 0 to 3 does the result, doesn't it? So Control and Shift. There we go. So it's actually showing you the result. So it's actually assembling it and showing you what it's doing. As 0 to 2 doesn't. There you go. So if you want to have a go, see if you do the spiral, right? You've already got the code, yeah? You've already got the code. If you use mode 7, which is this mode, the screen location is 7C00. That's where the start of screen is. It's still 40 by 25, is it 25? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, yes. So do it in line. Do it in line. Yeah? Well, if you have basic code, still do it. That is the poke command. Yeah? Yeah, so we're going to poke something in the top corner. So we'll do a CLS. Right, we'll come down a couple. So poke 7C00, so that's the top corner, equals there what? There's a 6. Yeah. Alright. That's your top corner. So it's 40 by 25. So it's exactly the same dimensions as the 64. Alright. Use whatever character you want to use. Yeah, I'm not, because I'm not too sure if we have an @ sign. Do we have an @ sign? Yes, we do. Now, what's the @ sign code? Oh, that's the question. What is the @ sign code? 64. Let's see. There you go. The @ sign is 64. Yeah, I've done it, mate. Right, the @ sign is 64. So, if yeah. So have a go, right? Because we will start using the VS Code method where we can develop it in VS Code, yeah. And then we can use the Beeb assembler to assemble it to the emulator. But I want you to understand how an 8-bit computer you could assemble inline in BASIC when the VIC-20 couldn't, the Commodore PET couldn't, 64 couldn't, Spectrum couldn't, Dragon 32 couldn't. And it's the power. So have a crack at it. Some people have got the code, you know. I've given you the start point of the screen, and I've given you the code, the poke code for the @ sign. Have a go at it. Now, if you need an example of how to do this, I can do it. I'm trying to figure out how to export. How do I export? Hang on. Here's the BBC file viewer. Ooh. DFS Explorer, is that the one I've got? No, I don't think that's the one I've got. Let's have a look. That's machine language. No, it's not the one. DFS Explorer. Ooh, maybe that's the one. Ah, here we go. Open. Oh no, it's just doing... Where is it? Download. Oh no, you gotta pay for it. Really? You gotta pay for it? No. spool saves the text. Where to? Come on then, Andy. Show me. Tell me how to do it.
Ladies and gentlemen, 6502 Kebab has entered the chat.
I really should change that to be bits instead of channel points. Go on then, how do you do spool, mate? Spool. Let's look in the manual. Star spool. Okay. Oh no. No. Oh, you're joking me. Good job, I saved it. Oh, it just needs tweaking, doesn't it? Right, just needs tweaking there. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, hang on. I'm looking at the wrong number. 1. Ugh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's where I need to go. Yep, that sorted it. Yeah, it's a control character, mate. You can make... There's an example in the manual where you can convert your keyboard into double I. Right, star spool listing. This is annoying as well. List. And how do we close it, mate? Do you just do star spool again? Okay. Right, I should be able to look at that now. You have a delay in your space internet. Wow. Right, let's see, I should be able to look at it now. Need to view it as text. So what I'll do is I'll get, hang on, I've still got this here, haven't I? Let me sort that out. see if this will see if this will install. If it does, let's have a look. Let's try it. Right, I should have DFF Explorer. Here we go. Open. View as text. There we go. This is what we want. So I should be able to open that up. View as text. Nice. Right, so let's grab that. And we'll put it in new file. Stick that in there. Right, let's just save that. Save as. Why have you why did you add yourself 10 points? That's just wrong. Right, I'll just put that there. Right. So there it is. That file explorer, I'm just going to grab, well, I've got it. And I'm going to put that in there. Can I create a right, let's do that. There we go. Right, so I can now look at disk files. Cool. Right. Alright, see you later. Right, so try and have a go. If you need an example, there we go. I've just exported it so I can put it in Discord or something like that. And try and see if you can do the spiral. I'll do the spiral as well. I'll convert my code into the spiral and see if we can get the spiral on the BBC as a way of learning how to code assembly inside of a BBC Basic program. And then we'll have a look at how we can do exactly the same thing using VS Code. I know 0-page hacks won't work. You're going to write it properly like the rest of us. So, any takers? Because I'm going to do it. And if you want me to put this A-level screen thingy on Discord, I will do. So you've got an example to work from. Yeah? I'm going to do it. I'm going to see if I'm going to have a look at this and see how inefficient it is. But there you go. That's how you can code machine code. So, yes, illegal code's not allowed. Have a go at it. Don't be afraid. The whole point of this is to learn on the BBC. We all know 6502, or we have a really good understanding of it. Let's see if we can start affecting the BBC. So mode 7 screen starts at 7C00. If you want to colorize it, you've got to be clever. Yeah, you got to be clever. But by next, let's have a little bit of a small challenge. Yeah, let's see if we can do the spiral on the BBC. And I'll start showing you how to get the VS Code development environment set up with the Beeb assembler, because I found a site with the Beeb assembler on it that's got the assembler for Linux, Mac OS, Windows. So there should be no reason why you can't do it. Alright. The big character challenge. Well, that's actually in the manual. It's one of the first tutorials, I think. Let's go back to the start. Oh, you mean the current challenge? Yeah, well, when somebody says they've done it in 96 bytes, I'm at 158, so I'm not going to get anywhere close to it. I don't know why I can't think. But yeah, we could do the kaleidoscope next. That'd be a good one, wouldn't it? Do the kaleidoscope. It's just a bit of fun, you know. No, well, it does. It does. That's Mr. Knight. That is very cheeky. Oh dear. Yeah, it has special characters. Let's find the double height stuff. Hang on, because it had an example to do the double height. Where was it? It was just a small assembly program. Oh, where was it? It wasn't that far in it. Oh. Was it? Or was it an FX? Oh, hang on, it could have been FX numbers. Polygon. Oh, I can't remember where it was now. No, it wasn't that far into it. It was somewhere in the introduction, I think. Somewhere around here. Not cassette. No. Keyboard. sure it was around here somewhere. That was using the keys. No, I'll find it. It was just a simple program that allowed you to do big letters. Right, Doxter, see you later. Oh, here we go. Here it is. Double height. Just grab that. Put that there. Grab that. Put that there. Right, let's paste it in here. So, new. Paste. Oh, that's still saving, isn't it? Yeah. How do we stop the spool? There we go. Yeah, that stopped it. Right, run. So this should be now. There you go. Big characters. Easy when you know how, ain't it? Alright then, guys. I think that's a good place to stop. So have a crack at doing the spiral using basic inline assembly, and next week we will start using VS Code and get you guys set up on VS Code so you can program in a assembly on there, and then it'll send it to the emulator. Right, well, thanks for joining me, and I will see you in the next stream. Take care, guys. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.